At this outcrop, we have claystones and thin sands that dip at 60 degrees to the south. In the distance, we see firstly Palmy's Point, and on the far left, we are seeing Roja Point. So here we have modern ripples on the beach, and we can use these ripple crests to get an idea of the direction in which our waves and currents are moving sediments. At this point, we are seeing a significantly different ripple. These are much larger, and you can clearly see that migration is seaward to shoreward. We are seeing red mangrove or rhizopora, and when we start looking at the pollen within the Pliocene deposits, we see that rhizopora is the most common pollen, and we can actually use the abundance or absence of these pollens to get an idea of advance and retreat of the Proto-Orinoco Delta. At this outcrop, we see a parallel laminated sand unit that has a slumped claystone unit at its base and thin parallel laminated claystones at its top. We have now arrived at Roja Point, where we are seeing slumped claystones underlaying sandstones, and then we have parallel bedded claystones above those sands. So, as usual, these claystones are very unstable and prone to slumping due to undermining by coastal erosion. Here we have a large disc-shaped boulder of sandstone at the base of the cliff, and we are approaching these south-dipping sand beds at Roja Point. So here we have a sandbed that is abruptly cut off. We're also seeing within the shale unit, we see what appears to be a flame structure. We are seeing claystone clasts, slumped clay units, we are seeing small intrabed faults, which suggests that these are syndepositional. Here we see steeply dipping beds on the west side of Roja Point. Dips are 67 degrees to the south. The well-bedded units are underlain by slumped sands and claystones.
At Roja Point, we have thick sand beds. The bedding is not clear and is capped by thinner alternating sands, siltstones, and claystones on the right. Within the massive sands are ophiomorpha.
We are now rounding Roja Point, which, as we see, can only be done at a very low tide. So here we see a big sandy unit. We see that is affected by a lot of fracturing.
Here we have thick structural sands capped by thin parallel bedded sands and thin claystones that dip at 67 degrees to the southeast. There are abundant gyrolithes, which is a left or right-handed downward spiral helix of uniform diameters of tube and whorl, or with or without scratch marks. It represents the dwelling burrow of a filter or suspension feeding organism. It is indicative of marginal marine environments. Macaroni ignis is usually interpreted as a shallow water trace fossil. It occurs in the beach to upper shore face and is commonly monospecific in highly bioturbated sands.
Approaching a fairly massive unit, and we now start to see evidence of bioturbation by fairly robust ophiomorpha. They predominantly appear to be parallel to the bedding, but there are a few that are vertical, suggesting that there are some few escape structures. Step back, we get an idea of the scale of this particular outcrop, and we see that the sands are kept by parallel bedded claystones and siltstones, which are also rippled, as we can see as we approach these beds here. There is also significant bioturbation of these units. We can see macaroni ignis present here, as well as a few other varieties. So here we are looking at what is called gyrolithes. So we have a fairly diverse ichnofauna here, which is suggesting a fairly marine type environment. We can see slumps within this claystone section.
Bedding is not prominent at this sand outcrop, except at the base of the cliff. In this outcrop of south-dipping sands, small normal faults and slump folds occur. In a slightly different view of the same outcrop, but looking east, bedding is not clear, but small normal faults and slump folds are still present. In this intensely faulted outcrop, throws are of the order of inches. The dark rounded boulders are clearly cut by the faults, but the outlines are not displaced. This suggests they are the result of post-faulting diagenesis.
In this sand outcrop here, we see a number of fractures that are perpendicular to the bedding. So we see some small normal faults, some dipping to the east, some dipping to the west, and the fault planes seem to have been mineralized. So here again we see even the large sand clasts are also faulted. Within these sands here we're seeing differential erosion of these lower perm calcite cemented clasts. Here we see a fold that has been disrupted, and we're actually looking along bedding plane in some of these cases. We see a few rare rounded burrows in this sand. So extensive normal faulting within these outcrops here. And we start to see the reappearance of ophiomorpha. In this case here, they tend to be vertical. But not as abundant. We now come to fairly abundant, robust ophiomorpha.
we see a fault couch zone in a sand outcrop. In this sand outcrop, we see a rock pedestal formed by differential erosion of the sands. Differential weathering of unevenly cemented rock give rise to large disc-shaped boulders. There are abundant small vertical ophiomorpha in the sandstone. If you have enjoyed the video to this point,